Why I prefer exceptions to error values. I'm very excited about this because I think exceptions are, in fact, the devil. I can think of one use case that I like him for. One. Why I prefer exceptions to error values. Exceptions are often a better way to handle errors than returning them as values. Huck Tua on that, my friends. Okay, I am not on this side. I am not on this side at all. Oh yeah, by the way, if you're learning to do game development, develop.games from Thor is very, very good. It has like every single possible link and all that. It's a great place to start from. It's like it can actually start from the beginning. Right. All right, back into this. We argue that traditional exceptions provide better user and developer experience and show that they even result in faster execution. I thought there was like a non-optimization case when there was a throw exception in there. Faster exception. I know. I'm curious about this. Okay, Philip. You let me know why. I'm ready. Hey, you know what? Let's go in with an open mind. Everybody on 3, let's breathe in. Waft it, and breathe out. Bad start, but I'm willing. Okay. Good error handling is the key to robust programs. Actually, you know what? This is so true. And for those that were here yesterday, when we created NeoVim to spawn a Go server that then takes in arguments and pass it back to NeoVim, execute things in NeoVim, and then pass it back through the Go server and then back to local NeoVim so that TJ and I could both program at the same time. Lua was much harder to get right than Go because Go errors in line. Very easy. You can just do them. Whereas Lua has this kind of weird, like, middle ground approach, which is, it is an error unless if you p-call it. If you p-call it, then it does errors as values, but if you don't, it throws it up. But often dreaded by programmers because there is always one more edge case. Traditional object-oriented programming languages use special exception classes that can be thrown to break the regular control flow for immediate error reporting. Let's take a quick look at an example that explores error-safe integer division. Classic. But I mean, if you're going to really do this, then you also should probably take this out during production mode versus, build mode, blah, blah, blah. Newer languages tend to favor functional style error reporting and encode errors in their return type. For example, Go encodes the error in the return type with res tuple, and Rust returns a result te, the sum type of a result and error. Even older languages such as C++ now include error values in their standard library with expected. Oh, nice. We can do expected. Oh, very cool. Hey, what a great way to do things. Nice. I like it. These functional style errors are intended to make error handling more explicit. By the way, I'm desperately holding my opinion right now. I want you to know this. I'm trying my hardest not to come in here and try to color how I'm reading this article. I'm trying very hard. This article is written as prime bait. I'm seething right now. I'm holding back. Let's just wait. Still, I rarely see code that users returns as hold on. All right, these functional style errors are intended to make error handling more explicit and to force programmers to think about errors. Still, I rarely see code that uses errors as return values fare better than exceptions. Quite the opposite, in fact. My anecdotal experience is that Rust code, for example, has more calls to unwrap than I'd like. Okay, but that is a pure skill issue. If you use unwrap, pure skill issue. Now, expect is a great way to have effectively an assertion, a runtime assertion about the state of the world, saying, I expect this to exist. There is no other universe that exists other than this. And then you can even give a nice error message, like lock, right? If you use a mutex on your server to house some sort of data and the lock gets poisoned, like that's it. That's the end of you are in a terrible place. You are in a terrible, terrible place. The problem here is that a simply unwrapping result will crash the program on errors that could have been a user visible error message with exceptions. Yeah, but again, this is not a good argument. Okay, this is just a misusage of Rust. And if you actually get if you get to the point where a program has no other option than to crash, is it some sort of message should be delivered? Yeah, this is not a good argument. I want to see a good argument here. So a result type's a mistake. It depends. They are definitely useful, but there are many cases where exceptions are much better fit. Let's see some. I want to see some. Your programming language of choice should allow you to use exceptions. However, in these languages, exceptions somehow have an undeserved bad reputation and cannot be used. I argue that exceptions are easier to work with as a programmer and result in better user-facing error messages. They're also more performant. In an example we'll see later, a C++ implementation using exceptions is about 4 times faster than Rust. Okay, I think that's also going to be a hard one, but okay. Okay, hey, let's let the man cook. Okay, we're cooking. We're cooking. Exceptions are much easier to work with. Keep in mind that I am writing this from the perspective of someone working on server-side code that maintains a significant amount of in-memory state. Okay, cool. This means that I prioritize keeping the server process running and would rather have a single request fail than the entire application crash. Okay, that's fair. Fair. To meet uptime SLAs, I want to handle any failure gracefully. Yes, even the ones where the abstract machine of our programming language fails and the real system limits show up. Memory isn't infinite. CPUs can't process all integers, and Santa isn't real. Whoa, buddy. Can't be just coming in here like that. While my perspective certainly isn't fully objective, I think other systems could benefit from similar approach. Even for front-end applications, I would rather see error dialog than a crash and loss of state. Again, none of this is saying anything thus far. And what I mean by that is that I personally prefer errors as values. And the reason being, in which is exactly what he is stating right here. I need to know every last thing that could potentially error, and I want to be able to handle that error gracefully all the way through. A thrown exception unwinds where you're at, and you could be in the middle of a function, and if you have an unknown exception being thrown, you could leave yourself in an odd state. Okay, Nightshade Dude, you can't let it go emote mode this long. I actually want to hear people's arguments here. This is too long. This is too long. You're abusing your privileges here. Too long. Why can't you do that with catching exceptions? The reason why you can't do that with catching exceptions is actually rather trivial. Here, let me explain why. Is that when it comes to catching exceptions, why aren't you becoming bigger? There you go. Oh man, that is way too tiny. That is way too tiny. I don't know. I just gave random numbers. All right. The reason why it's harder with catch exceptions is that let's just say we have a theoretical function named foo that can error. All right. Now in languages like JavaScript, you actually don't know if this thing can or cannot error. All right. It's a complete surprise for you. So you don't actually even know. In other languages like Java, it'll have some sort of annotation to it. A little bit different. But if you call this and say you're down the stack A, B, C, and then this function has an exception, depending on the state here, especially if you have a high, like as he was originally stating right here, is he has a significant amount of in-memory state server. So if an exception happens here, where is it caught? Do you even know? You can't know because you would have to have the understanding of what came before it. So it's actually impossible for you to know, is it A? Is it B? Is it C? And if an exception happens within foo, and you do not have it handled, or say within C and you do not have it handled, well, guess what? Whatever state you have changed in C that does not have an unwinding will have some weird experience later on in the program. Whereas errors as values, you have to make a decision at that point how you want to handle an error. If there is an error, do you crash the request and go straight to 500? Do you handle that and give some sort of default value out? You have to make all these decisions. And if you want true, good exception handling, what you'll find is that you litter your code base with try-catch everywhere. You cannot just rely on top-level stuff, especially if you have any sort of in-memory state. You don't have to handle it at foo. You could return. Well, that's the nice part, is when you have errors as values, you can make that decision because now you have this error object, and what do we do with it? Do we have a default value, a good default value? Hey, service, give me the default amount of things I should show to the user. Ah, crap, request failed in your theoretical super microservice services. All right, 20. 20 is my default one, right? I don't have to try catch it. I just know I can do even some nice monadic transfers or else, right? And have these nice little operations that just happen on top of it and transform the error into the thing I want it to be. And so exceptions just don't give you these type of operation options. And often what I see is it's just always caught far up the top. Do you mean that libraries shouldn't throw exceptions? Well, I think the library should operate in the way in which the language behaves. So in JavaScript, I think it's kind of weird to try to make result happen, right? I just think it's kind of weird to try to make some sort of error as value in a JavaScript library, because that is not how JavaScript operates. Typically, that's not how it operates. And so I find it, you have to think about it differently. Like, when should you throw? Why should you throw? Should you return an error value? What does it mean to return an error value versus throwing an error value in JavaScript? There's a lot of implications in it. Throwing a value is almost like stating, I have gotten into a faulty state and I can no longer operate. Whereas returning an error says, hey, I did something, I was able to recover, but here is why I couldn't proceed with your request. It's almost like a very different kind of feel. And that's one of the problems with this, like, these JavaScript-y type languages where you can do both returning and throwing, is that you have to have this whole, like, you have to have all this, like, implicit connections between what is being returned and why. All right. For our server programs, we also have a good way to handle errors. Send an error message to the client, and if that doesn't work, close the connection. Yes, even for out-of-memory situations and SIG FPE, which you get for division by 0. You can send an error message instead of panicking your whole system. Again, you do not even have to panic your whole system on a divide by 0. I assume he's saying something against Rust, and it's divide by 0, but if I'm not mistaken, a divide by 0 does not crash the program in production, but in development, it does crash the program to help give you understanding that you are doing a divide by 0. I believe Zig does the same thing, if I'm not mistaken. While shutting everything down is certainly safe, it is not very productive and is a potential DOS vector. It is potential DOS vector. This is true. But again, returning errors, like if I knew I could cause an exception to be thrown in your system, I could cause exceptions to be thrown in your system. And if you don't handle them properly, I could potentially cause errors in your systems in such ways that shut down your entire server. I don't see any difference here in this argument. Exceptions make this extraordinarily easy. I do not see how this makes it any easier or less easy. No matter where you are, 100 call stacks deep in your little corner of the program, you detect an error, so you throw an exception. Which call stack handles it? How do you know the above state doesn't get effed? Did the above state expect it to be thrown? How do you know, right? Like, there's so much implicit knowledge here that is just being completely thrown out right now, and it frustrates me. Okay. All the hard work is now done automatically in stack unwinding. On Linux, this is typically done in libgcc, which determines how to unwind through a binary with dwarf frame. Frame. The beauty of unwinding is that all the destructors are called, all resources are handles are dropped, and locks that are currently held anywhere are released. How is that true at all? Isn't that only true for things that, like, I'd have to think about that, because this is not always true. If you allocate something on the heap and you do not clean it up, then guess what? This is why defer error exists in Zig, because if you have an error that causes this thing to return due to an error, it then allows you to clean up the resources. It's true in C++. I don't believe you. I don't believe that if you call new in a function on a variable, and then somewhere even further down an exception causes, that it automatically calls delete for you on that variable. Does it call delete for you? Am I wrong on that? I could be wrong on that. No, I never said anything about a unique pointer. That's different. I didn't say anything about a unique pointer or shared pointers. I said new. So I'm sitting here thinking, what do you mean? When did C++ get this implicit behavior? I am not familiar with said that. No, you need to delete specifically. Therefore, guess what? These are in fact not called. Okay? So there is no handling resource drops. If you open a file, that file doesn't magically get closed. That's why I use smart pointers. Of course you use smart pointers, but there was something implicit there. Notice that it wasn't there was a lot of implicit kind of stuff. Not with that attitude. There was a lot of implicit stuff in here that I do not believe is true. Best of all, this magic happens behind the scenes. No, if you Malik, you got a free dog. There's no, what? This magic happens behind the scenes because your compiler already emits the correct unwind info. So a simple try-catch block at the top of the connection handling is enough to gracefully handle the error and report it to the client. I'm pretty sure this doesn't even happen in Go. And Go is garbage collected. If you create a TCP server and you start listening and then you return out of the function, you're still using the port. The port is forever used despite it never being useful again. Boilerplate. If you panic and you don't have some sort of error defer, you'll actually continue to listen to it, and you have that stupid operating system problem where like your port will be being used despite no program being used. Compare this functional style errors. Well, let's see, where error handling is manual and super tedious. You have to explicitly check if the error value is an error and propagate it. You would have to write the same boilerplate if error, return error over and over again, which litters your code base. Yeah, some of them do something better, right? When it comes to Rust, you got the question mark operator. When it comes to Zig, you have the try operator on that, and it effectively does all of this for you. I actually personally love if error does not equal nil. The reason why I love if error does not equal nil is that it tells me it's time to think about this, because I often find myself deferring to higher levels in Rust because it's really simple to do a question mark. The question mark is so simple that it allows me to not think through my errors nearly as holistically. I don't get the argument that if error does not equal is bad. I don't think it's bad either. Well, he's just saying boilerplate is bad. I don't think boilerplate is bad. I don't think boilerplate is bad. So it's bad because you don't think it? No, I just don't think that this. I don't think that saying you have to write code to handle errors is bad. I think fundamentally that statement is incorrect. Writing code to handle errors is good if you want reliable services. This is why I always say it's extremely hard to make a reliable service in JavaScript. It's extremely easy to make a reliable service in Go. Because one, I have no idea where and when and how errors are caused. In another one, I do. An easy, very simple one that gets all new people and even experienced people in Node. This is like the classic one that gets everybody. Is that I can go like this. JSON parse. There you go. A lot of people have no idea, and they like this is the classic. We actually took down production because we JSON parsed without realizing that we could hand non-JSON to this parse and that it could blow up. Like this is the classic one, and every last person has crashed production because of this one issue. And the reason why you've crashed this is because you don't have anything that told you this thing could throw. Now you start using libraries. Maybe one of the library functions doesn't wrap this, and it crashes despite the fact that you had no idea that it is even using that. Stop targeting me, Prime. But it just is, right? Because if you go like this, if I go Marshall, right? Unmarshall? Yeah, there you go. You'll notice that when I JSON parse and Go, I have to handle this. So in my code to determine who gets to type in NeoVim during our little two idiots, one keyboard, I could make that decision right here. If I was unable to marshal this data, I had to handle the error. I have to check. It's right there. I must check it. I need to figure it out, which I think is fantastic. Let's briefly look at some code metrics for two similarly sized database projects. CockroachDB, a Go project with explicit errors. Okay, nearly 25,000 error handling paths. Okay, hold on. Well, let's let them cook. Most of these errors are artifacts of repetitive pass-through reporting style, but there are quite a few instances that they are simply used for log fatal. This doesn't look very graceful to me. There are reasons why your database should crash. If there is an error in something that cannot move forward, there is a good reason to crash. CedarDB, the project we're looking at that uses C++ exceptions, catch, there's only 140 of them. Let's pretend that CedarDB and CockroachDB have the same amount of errors they are handling. I would like to argue that this shows you where all the possible errors are, and there's probably a bunch of unique decisions. Whereas 140 means that you have to compact all of these decisions into a fewer amount of decision points. I'm not sure if that's good. I don't have any reliable metric to say that more or less error handling is in fact good or bad. And not only that, if you wanted to find the full extent of this, you probably would do something like does not equal nil, because there's actually ways to do compound if statements in Go. I could do something like this, right? If right, like actually that probably would have been a better way to do it, and I did not do it that way. But this is a nice little more compound if statement right here to be able to do that. I just don't see how this number is a good argument for or against. It's just a number. I don't know if this means you don't handle errors good enough, or that you found every single point in which errors could potentially happen that need to be handled and unwind stuff. Like I have no way for me to understand it. Over 100x less code. That does not mean something's good. Less code does not equal better. It has never equaled better. More code does not equal better either, unless if it's an explicit algorithm that we all know, like quicksort. If your quicksort has 10x more code than mine, either I have incorrectly implemented quicksort or you've done something crazy, right? Less code equals better. Yeah, that's a crazy statement to make because you can't make that statement. I have never been able to make that statement. At first glance, most of it is either in test. It's like what's called actions per minute of professional StarCraft players. Professional StarCraft players, there's a lot of redundant clicking, right? You can go, and so how much? So a better metric, I think, would be meaningful actions per minute. How many meaningful actions per minute are you doing? Not all clicks are created equal. You could make the exact same thing here, which is more code does not necessarily equal better or worse. I know a lot of people are saying no code means better or worse. Have you ever seen code that is really, the problem with that metric is that it could immediately lead into horrible code. Effective APM does exist. Yeah, and I think effective APM is very, very good. But imagine if that metric became important to you or your boss. Can you imagine what kind of code potentially would become produced? Just like when people try to measure lines of code and then all of a sudden things get really long, you will game whatever metric you create. I don't think it's a good idea to say, the right code for the right situation is the right amount of code. That's that. They measure lines of code at Meta. Yeah, that's crazy, right? Paid per line of code. Yeah. The right amount of code for the right situation is the correct amount of code. That's it. Of course, there are solutions to reduce the amount of boilerplate. In Rust, you can sugarcoat the ugly syntax with a question macro. It's not a macro. At least I don't think it's a macro. I'm pretty sure because a macro actually generates code. I don't think this thing generates code. I think it's just an operation. It's just an operator. This just hides all the tedious checking, but you still need to do all the work. Additionally, your function now returns error codes, which means that you have to change the public interface and recursively change all functions that call this function instead of working in your little corner. Your extra, okay. Again, I'm going to defeat this argument. Your extra little check now propagates to half the code base. On the other hand, there's always the temptation of a little unwrap. Surely that snake won't bite you. First off, there is not that temptation. If you use unwrap, you are saying, I am fine with my program crashing at this point. Okay? That is true. Now, why does this not bother me? I'll tell you this one. When you use the question mark operator, you are stating explicitly, if an error happens here, I cannot handle it, and I just want the person above me to calling understand that may have more context, handle the error. And if the person above you says, I can't handle the error either, and they pass it above. But what ends up happening is at some point within your program, you have something like an or else, or you have some sort of expect, or something else, and you end up changing the actual interface because you, at that proper point, know how to handle those errors, right? Isn't this something similar to coloring functions? Sort of. It's not quite the same as coloring functions. But yeah, I guess you could argue that this is something to function coloring, which I am for when it comes to errors. Because you want to have to in my opinion, I think you should forcefully need to think about errors. If you want to write robust code, forceful error thought is the only possible way I can see. System errors. What if I told you that most programs already handle far fewer errors than they should? Think back to the safe div example and try dividing negative 2 to the 32 by negative 1. That would result in 2 to the 32, but that's out of range for an int. Oopsie doodles for a 32-bit int, to be fair. So are you sure that your program doesn't crash? Do you add an error result whenever a function asserts something? Well, again, I think Cedar would do a really good job checking out Tiger Beetle. Tiger Beetle uses what NASA does and actually crashes when they reach a state that's unreachable. And it's a very impressive piece of technology. In fact, I would argue that Tiger Beetle is perhaps one of the greatest pieces of created technology in the last 4 to 5 years. And so, what is Tiger Beetle? Tiger Beetle is a database. It's another database. It's the financial transaction database that uses simulation testing, and it has 2 asserts per function as effectively a minimum requirement. And so if you go here, it's called Tiger Style. There you go, Tiger Style programming. They have a whole thing on this. It's absolutely amazing. I've embraced a little bit of this, which has to do when it comes to asserts. And this has to do with NASA, right? NASA is this whole NASA. Do they have the NASA document linked here? There you go. And this is a NASA document for how to create NASA level stuff, and they use asserts, which crash a program. And they have satellites that they are waking up that are like 30 years old. So whatever they're doing great. And so I like that. I like what they have to say. It's a pretty interesting way to think about software. Anyways, all right, let's see. Did your add an error result whenever your function asserts something? But there's so much more. Allocations can fail. The stack overflow. Let's see. The stack can overflow, and arithmetic operations can underflow without involving exceptions. Let's see. Without throwing exceptions, these failure modes are often simply hidden. Calling an inconspicuous function, stack overflow. Oops, your server is gone. Add 2 values, panic at the Rust disco. That's only in dev. If I am not mistaken, panic on overflow Rust. I'm pretty sure when you're compiling in debug mode, Rust includes checks for integer overflows that cause your program to panic at runtime, right? When you're compiling in release mode, the release flag, Rust does not include these checks, right? Which is great. This is actually a great thing. You get to know when you done messed up. Like, that's a great thing. Asserts are a debug mode only thing. So Tiger Beetle does asserts in production, which is pretty cool. Like, it handles everything. The writing is cute, but not especially thoughtful. The writing is great. I do like the writing in Hit. This is good writing, by the way. Assigning this temporary object, say hello to killer. Whenever any part of your code flow is user controlled and what isn't, these errors can happen. It's pretty wild to attempt to handle an I'd have to understand more about it, how you would even handle an You can't even open a file handle to write out your stuff. Like, you got no more memory, bro. Like, you're completely out. What are you doing? Is database crashing conventional in production? In Tiger Beetle, it is, but they don't crash because they've created such a resilient program that handles all errors in the correct position and asserts all states that need to be correct at all times, and it forces everything to be in a very specific way of operating. And they've been able to understand effectively every single possible error that could ever possibly happen, and now they effectively have no problems. It's a very, very cool way to approach a problem. For memory allocations, you're most likely out of luck in Go because it's GC. I have more hope for Rust, where the kernel integration work is slowly forcing it to grow up and build some more reliable interfaces that don't panic, e.g. box try new. But this will require refactoring all existing code. Yeah, I was thinking about Go, but I guess this is one good argument. I think this underlying argument he's attempting to make is good in the sense that when you do a new circle and you have no memory left, you get an exception that you can catch and you can do something when you get an Is that I assume that's the argument he is making. But I would love to see what you could do when you get an that is anything other than crashing. But then what? Yeah, I am just curious what the resulting thing is. Anyways, still, I'm amazed that this is supposed to be the state of the art for systems programming. So I know programs that when they get to this point, they get they actually have a system crash that when things crash, they write out a crash state to a lock file effectively. And when another startup happens, it reads that lock file. And if that lock file is present and it has this crash information, and then upon next start, it's able to take that and report it to a server. Maybe a game hits unloads a bunch of textures and reattempts. What is an out of memory? Yeah, it's out of memory error. I'd have to think about that more because even unloading textures can create, you might have to create memory to unload memory. Which if you cannot create any more memory, it's actually really hard to do something. Out of mana. It stands for out of mana. Hey, thank you, Hotstack, for the raid. I appreciate that. Yeah, Hotstack. I've never had to really think too deeply about this. So maybe there's a really good point he's making right here. And I recognize that not being able to handle an out of memory exception or some other one of these kind of bizarre exceptions that are at the system level is a good argument for why, because your interface does not provide it. Just like when you do a new in C++, maybe there's some hidden mechanism that does it, whereas malloc does, right? Malloc does return the proper item. Oh, my camera died. Hold on. Hodl. I've been having camera problems. I'll explain it. It's not out of memory. It's out of battery. It's an OOB. It's an OOB. It's an OOB. Just hold on. I'll be doing this swapping for a little bit. I'm getting... I don't know what's happened, but I've had not one but two separate cables break. And I am unable to keep my camera charged, so I'm doing this like battery swapping thing. So, you know, I can't really help this one. It's Hot Shack, but you're gonna get it someday. Oh, have I been calling you Hot Stack? I have an uncanny ability to misread things. You would not believe my abilities. No worries, I'm doofus. Yeah, I do. Just so you know. Exceptions lead to better error messages, but with more explicit error handling closer to the error source, you surely get better error messages. Again, my experience is the opposite. Return error values often have little information and lead to bad error messages. I don't see how that's true. Again, this just sounds like what you're saying is that the person who created the return error did not add any information or put anything on it, but I would also assume that the person who would throw an error would do the exact same thing, right? The classic example is syscalls, which usually follow C conventions. There, the return value is often just a code -1. What the actual reason passed as a side channel via error. Ooh, good old-fashioned error. For what reason? Getting a reasonable reason why something failed is often not possible from the error code alone, but requires significant context around the calling code. Yeah, okay, but this doesn't exist in other languages. I get that this is like a C unfun thing, but a lot of people wrap these things and provide a better experience. What do you do now? Standard string error tells you invalid argument. Great. The system probably knows exactly what went wrong, but refuses to tell you the details. So the error no alone is not really helpful. For proper error messages, you need the syscalls as context, but even then, the errors remain obscured. Consider write to, which could return inval, either for an object which is unsuitable for writing or for misaligned buffers. But which one is it? I feel like this is a bit of a bad faith argument right here, because an exception, you're using C as the example, but other programs properly give back what has gone wrong. And so I kind of feel like this is an unfair argument against errors as values, because it's doing the craziest form of error handling, which is Sentinel globals. Sentinel globals with some level of hiding. Well, like standard C, when you're using just like basic C, you don't often give back. You don't get a lot of those errors back, right? You have to use error no. If you have an exception doing Berkeley sockets, you have an error no value of some blah 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 blah, right? So I'm not saying that I understand the argument here, but I'm saying that this is also a very bad version of it, because any modern language, and when I say modern, I'm not even talking about that old, would give you the error. Yeah. Yes. It would give you the proper error back. This argument it's not even a skill issue. It's just using a much older version. It's using a language in which does not give you that information and then telling you why this makes errors as values bad. This would be a red herring argument. This is a straw man argument. Errors as values and error no are different things. They're not the same. Newer languages do this a bit better, but Rust errors also fall into the error kind trap. We parse int somewhere, and an error kind invalid digit bubbles up at the user. Here am I. Let's see. Here I am parsing megabytes of CSV, and you tell me invalid digit found in string. Call that job satisfaction? Of course. There are non-standard crates like anyhow that do this better. But in my experience, error return values only encourage bad errors. No, again, this was just not properly handled. If you're parsing CSV and there's an error, I would assume that someone would get int error kind invalid digit, and then to be able to take that information and say this is where it's happening. And you know what? Let's just be real for a second. If this was an exception, guess what would have happened? You would have had bad parse error, int error, and that would have just simply been thrown up. I don't see how this is either side. And for those that don't know, anyhow allows you to do this context field. It adds something called a context trait onto a result object, which allows you to be able to go like dot context. I was in this position doing this stuff, so here you go. Here's what went wrong. And so that way each single level can add more and more stuff. right? But in my experience, return error values only encourage bad errors. For a proper error message, you need to capture significant context in the error path, which does not fit into a simple error code. Again, return errors do not have just a return code. What you're saying is, this is correct. I actually fully agree with this. If you want to do a proper error message, you need to capture significant context in the error path. Absolutely. Hands down, 100% correct. But that is orthogonal to exceptions or errors as values. I would argue that errors as values allow you every single step of the way until handled to capture context and returns any extra non-stack trace-based context. I would argue that it's actually easier to do what you're saying in errors as values. Because let's go back to this. Let's say A is the try catch, or A is where we handle the error. Foo is where the error happens. In a proper error handling thing, C could then go, okay, here's my state, here's what has happened, wrapping it up, adding it, wrapping the error, returning it. B could say, hey, this is what I'm doing. Now notice this is not stack traces. This is actually something more useful. This is giving out that extra bit of information, okay? It's a me result object, right? Like it's better information, and therefore I'm able to take that information and again, wrap it with B, whatever extra information I need around B. Then A comes around, and then A could have this really intensive, explicit error that it contains all of the goodness. Whereas with try catch, you miss all of that, plus you better hope they handled state correction. Resolve this, Mario. Sorry, I've kind of lost my voice due to how much streaming I've done lately, so my It's a Me Mario is not as good as it normally is, okay? I'm sorry. Instead, you probably need to allocate a dynamic error, just like with exceptions. For debugging purposes, you may also want to include a backtrace. Now you have exceptions with extra steps. Well, you get a backtrace only the things you really want to backtrace. That's the nice part, is it's also even more. It's like, I'm surprised at this argument. I feel like this argument was just a really bad argument. He's saying people that have errors as values do a shitty job, but people that throw exceptions gather all the state and properly report an error. Like that's like a really, you just like straw man super hard. Exceptions are more performant. Exceptions have one last ace up their sleeve. They have zero overhead on success because we separate the control flow. Instead, error return values intermingle the error and the happy path and always require a check and branch for error handling. What? Yeah. I mean, I agree. It's nice to write happy path code, but happy path only code also makes really bizarre control flow and potentially dangling state problems. By the way, is my volume kind of acting goofy? I'm having this really weird hearing thing where I sound really clear and then I sound not so clear, then not so clear. Okay, seems fine. Okay, my monitoring is getting off. Okay, I just wanted to make sure because I always, like right now, it sounds muted for a second and now it's back. Your voice is goofy, but the regular goofy. Okay, good. Thank you. I just wanted that clarification. All right. This is not free and introduces overhead for each result. Let's look at the following example, a function that recursively calculates the famous Fibonacci numbers. Oh, man, this is going to be like the world's worst version. I guarantee you, this is going to be the world's worst version. To avoid overflows, we report an error on large calculation depths. The following example uses C++ code, which allows you to compare both versions like this. Unsigned, do fib throws, this one. If max depth, throw. Return this, do fibs this way. Okay, standard, expect this one. Do all this. Okay, we can see all this kind of stuff. Unsigned n, max depth. There we go. We do all this thing. Blah, 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 blah. Even pointer dereferencing, which I'm a bit curious about that. Okay. I see how this works. Okay, I see how this thing works. Yeah. Gets the value out. Yep, I see that. Sorry, I've never used standard unexpected. So this is the first time I've ever done a standard unexpected. I did not know about this. Okay, that makes sense. So that just gets the error out. That's a lift operation, right? So we'd call it, I believe typically we call it a lift. The expected version. So I will say that my guess is that he wrote the world's worst code. The expected version is a bit more verbose, but essentially does the same code, right? Then it should run the same. Is anybody here surprised? I do feel like, first off, this is just a very shitty way to do this. Okay, it just feels like you're really attempting, right? I feel like what is this throws as it is? Not max depth. It just feels like you're trying to write the world's shittiest code to prove that if you don't do any of these extra allocations, it is in fact faster, which I do agree. It is in fact faster to not do things. You're right. You're hands down absolutely right. That doesn't mean it's better. It just means you're right. The secret with performance is if you can just do less, it's faster. Like, that's it. That's it. That's the only thing. With C++ exceptions, 10K iterations at n equals 15 run in 7.7 milliseconds with standard exception return values. It takes 37 seconds, almost 5x the runtime. See the quick bench. Rust version is slightly faster than the C++ version, but still 4x slower than throwing version. But you have... I gotta go pee. I just gotta leave for a sec. I have to leave. I'm no longer angry. Yes, it's doing a type loop exception. Me personally, I would have done a much different thing. Okay, so I want to understand this a little bit more right here. So what is max depth? Can somebody help me understand this? All right, hold on. Do fib expected, unsigned n, unsigned max depth, if not max depth. Okay, so I don't understand that. So if max depth is 0, then guys, I'm going to help you. I'm going to help you guys. All right, I know I'm in Go, so just deal with it. I'm in Go, so just deal with it. I'm going to help you. Watch this. Are you ready? Are you ready for this one? Maybe there's some other thing you could do here that would make more sense. I am having a hard time seeing this entire thing. This feels weird. Okay, this whole thing feels weird right here. I don't know. It just is it's a strange way. Like, this whole thing is such a strange function. Why are you throwing exceptions or handling errors? Why are there errors at all in this? Right? Like, all of this seems strange. It seems like if you were to do this, you'd have something like function, run a fib as a service, and then you'd have some sort of like incoming n int, and then you go in here and be like, if incoming is greater than some sort of max thing, therefore return a 500, return 500 on bad case, else do the good thing, right? It just seems like a weird place to handle the error, right? Like, why are you handling this error right here when you already have that information plainly available to you? Also, create a DB table while you're in there. Hey, just throw a quick DB table. Primogen, instead of doing this, they could just calculate the Fibonacci directly with the Binet's formula in O of 1 time, since it's just comparing two completely different things for no reason. I know. They could have also just done the iterative approach, which is also super fast. It just feels like this feels like a very contrived example of trying to make something the worst possible version. I'm going to make the tightest loop something that explodes in function calls, and I'm going to show you that if I don't have to handle this, that it's in fact faster, which you're right. If you can return just an unsigned integer, there's less stack allocations. I have no idea what standard expected does either. Does standard expected do some sort of heap allocation? I just have no idea. I don't know how these things work. Uncle Bob intensifies recursive thinking. This just all feels like... I will say this. Can I just go back? He actually makes an exceptionally good argument right here, okay? This is an exceptionally good argument. You know why this is a great argument? Pretend I'm in Rust for a second. How does this fail, right? This is a great argument for Rust. This could potentially How do you handle it? Well, you don't. You don't actually handle this right? Or if you did this, right, let A equals this, and then you went A.clone, right? Let B equals this, right? Like, that's actually at least a real argument that he's making, which I actually really like. Try new, but I know there's a try new, but that would be how you have to handle it. You actually have to call a completely different method called try new, but almost nobody even knows about that, right? So I'd say that this was at least a very good argument. Now, Zig, on the other hand, Zig does not have that problem because Zig forces you to use an allocator and allocate on all explicit allocations. So it actually would prevent you from making this oopsie daisy. So this was a great argument. but still falls short because he's comparing a language that didn't have the constructs to ensure that these things worked. That's it. Zig doesn't have context and errors, though. That's true. Zig does not have the context and errors that it's needed. So I think Zig has its own downfall, but Zig also would have allowed you to be able to have an and then for you to be able to take that and make a decision based off of an I do agree, though, that Zig's whole argument against sum types and all that is an interesting one. Yes, stands for out of mana. All right. Why are return errors? Why are error return values so much slower? The obvious reason is that we have error checks and branches that does not explain everything. You might expect your CPU to quickly learn to predict branches. First off, I never rely on those things, though. That's a crazy way to do stuff, which are essentially free, right? This hides the fact that each of these checks silently consumes usually invisible resources of your CPU, such as instruction cache, UPOP cache, or a micro-op cache, a branch history buffer, reorder buffer, and so on. Since almost any function can fail, remember that allocations in math can and will fail. Checking all various errors in lines takes up significant amount of resources that can't be useful for code. Exceptions are handled in completely different code path, usually outlined in cold sections, which already gives them a solid advantage. Another thing, by the way, that he's not mentioning in the Tiger style, you're not allowed to use. You're supposedly not allowed to use things like unsigned or usize. You use int32. You always have a defined size, and then you put those expectations around things. You assert that you cannot walk into a specific case. The thing is the cost is actually dwarfed by any real computation. Yes. As far as performance go, I just assumed everybody understood how ridiculous this was, and his argument is actually correct. This is actually a correct argument, which I agree with in some sense. But nobody in a real application is doing this type of stuff. And if you are doing this, say like in the Havoc math engine and physics engine, you're doing no error checking at all. You're running numbers. You're crunching numbers. I would be shocked to see result objects in a physics engine being passed all around, because that's just not happening. It's a contrived example to make a bad point. Yeah, you're kernel panicking on air. It's the truest no Scotsman. Another difference is that instead of returning a simple int, we now return a fat result object. This makes the call significantly more expensive, since we now have to shuffle the values through the stack, which requires additional setup and teardown. In the success case, we now also need to convert the fat result to the actual value. This can prevent compiler optimization such as tail call optimization. Oh, I didn't know that. If this is real, I did not know that. In general, the functional style error propagation uses more registers and stack space. By the way, isn't Fibonacci not even tail call recursively optimizable because you can't? Because you just can't anyways? I thought it wasn't even possible to begin with. I could be stupid. I don't know a lot about tail call optimization stuff. I just always thought it falls into it only if it's the very last thing. Fib is not tail call. I thought fib is not a tail call. We don't give back errors in physics engines. We just give our best answers. Iterative solvers are the way, baby. Yeah, one would assume. Yeah. Another difference is that instead of simply returning an int, I already read this. This can prevent compiler optimizations such as tail call optimization, which that could be true. I have no idea. I'm just going to assume on good faith that he's telling the truth. In general, the functional style error propagation use more registers and stack space, which in turn leads to less inlining. Of course, you can try to work around these problems by allocating errors somewhere on the page, such as thread local storage. This is what exceptions do. I have no idea anything about that. Again, I just feel like this is just a wild version. Throwing exceptions used to be terribly slow. Yes, I was under this impression, but I must be wrong, which is fine. But where did exceptions get their bad reputation? I think this was mostly due to the quality of their implementation. It's funny that when it comes to exceptions, he's so willing to make the concession that better implementations lead to better results. But when it comes to error handling as values, the fundamental exception is that there is no better because everyone's lazy. Throwing exceptions have always been expected to be quite slow. So for a long time, this code path did not get much performance work, and thus was frankly terrible. That luckily has changed to the benefit of the entire ecosystem. Propagation with stack unwinding is still up to an order of magnitude slower than regular returns from a function. But remember how we get useful error messages for return. But remember how we get useful error messages for error returns? How? We also capture the stack trace with the same mechanism, so better unwinding benefits both sides. But You get them on both either way. But you get them on both. You get them on both either way. You don't get this. I'm struggling on these ones. One, I'm just struggling on this argument in general because he said they're slow, they're 10x slower, but trust me, they're actually better because. But why? The arguments are mostly sane. They just have nothing to do with exceptions versus error handling. Yes, the hard part is I'm relating all the arguments back to error handling. And so I do like automatic stack capturing. I agree. That's actually really great. Can we all agree to that one? Absolutely fantastic. I don't have to Rust backtrace equals 1 to backtrace result objects. It is better. I totally agree. One argument for having slow exceptions is that getting a response from the user is even slower. Any error condition that bubbles up to bother a user or triggers a network message is usually fine to handle with an exception. For other checks where we have a fallback path that doesn't require an outside decision, such as checking for a cache hit, it's probably better to use some kind of local return code. This way, exceptions can often be avoided on critical paths, and their slower performance really doesn't matter. But you can make the exact same arguments with errors as values, right? If you can avoid throwing an exception, you can avoid an error as a value. You can just say, hey, you know what? I'm just going to return out a 1. We're going to do some sort of local things. We're going to just do all the locals, right? However, stack unwinding used to have a big problem. It was globally synchronized. To find the stack frame locations in the binary, we need to look at the global symbol table, which is then used to find the unwind information from the current function. I read that wrong, of the current function. As already mentioned, these symbols live in the frame section of the dwarf format. This information is usually static, generated at compile time, and it usually doesn't need to be synchronized. However, programs can also load code dynamically with DL open, e.g. load plugins or the JIT compilation. Yep. The problem here is that we need a mutable data structure where we can dynamically update the unwind info for the new code. To protect this structure, libgc just slapped a mutex around this code and called it a day. Now, only one single exception can be thrown concurrently, even on a 100-core machine. With high concurrency and many concurrent clients, this becomes a bottleneck. Fortunately, libgc now has the functionality to make the entire unwind process lock-free. In simple cases, such as when no dynamic stack frames are loaded, there is no reason to use locks. The dynamic case is a bit more tricky, but our co-founder, Thomas Newman, has committed an implementation of a B-tree with optimistic lock coupling for those dynamic sections. Oh, that's cool. That's kind of a cool thing you got there. And that makes sense, a B-tree, because that way you can kind of separate out the various parts so you don't have to lock large branches. That's a very DB approach, right? Founder mode mentioned. Let's go. Founder mode. Co-founder mode, by the way. So let's see. Even so, unwinding is still more expensive than it needs to be. For stack unwinding, the dwarf frame tables are essentially interpreted, which leaves room for improvement. There are some academic proposals, such as reliable and fast dwarf-based stack unwinding, to compile the unwind tables into native code, which promises to be an order of magnitude faster than the current exceptions. Oh, that's nice. That's cool. I do feel like none of this has anything to do with exceptions. One would assume that errors as values, you could get a stack trace. You could unwind the stack. There's something that you could do to do all this. I don't know. It just feels kind of weird. And can we be real for a second? How often do you look at a stack trace in a try-catch? It only does it when you crash the program, right? So it kind of feels like this argument is kind of like a null argument, meaning that the context you're looking for really only becomes visible in situations in which you look at the stack trace. I look at stack traces all the time, but not in just standard error handling. Right? You would never be like node, try what's it called? JSON parse something, and then catch and then do some sort of stack. Like you wouldn't do this in application code. Stack inspection in the application level would be kind of weird to do. I wouldn't even be really sure what you'd be looking for. I'd have to really think about that. I think that you need to build it with stack traces when throwing an exception, not when catching it. Yeah, catch, log. I know that what a stack error looks like. You wouldn't steal an exception, would you? Debuggers exist. I'm just saying it's a weird, like I'm on his team. I'm totally on this team that getting good stack exceptions and all that. So low-level learning was saying something, and I want to hear his opinion on this one. Let's see. You could unwind the stack, but you wouldn't know what function was being called. Yeah, but if you crash the program from a result, wouldn't you be able to, at least from that point forward, wouldn't you be able to get the stack trace? I guess you could argue since you got the result object, you couldn't get the underlying stack trace that produced the result object, and you'd only get the anyhow. Yeah, in a crash. I think they're trying to gracefully restore. Yeah. Okay. Final thoughts. In my opinion, exceptions have several advantages over error return values. Exceptions provide separations of concerns by keeping error path distinct. Sort of. Sometimes it makes it way worse. It can sometimes make it way worse. Like if you've ever seen any await code, any async code in JavaScript or in any code that's async, like any Rust code that's async, any async handling code at all, results in every single async call can also be an error. And if you have async code that isn't considering error, you just simply aren't considering your error path. Results with error codes can hide system level errors such as out of memory or overflows. Sort of. I mean, I agree that you have to do try new versus new, which is, one could argue, skill issues. 99% of applications don't need to consider out of memory exceptions. So you could argue that if you're writing an application that needs to consider out of memory exceptions, then maybe you need to use the try new versus the new. Fair argument. And I think that this is a very good argument right here for a reason why having errors that can bubble up and handlers that can handle like errors that are unknown is a good thing. Exceptions make it easy to provide root cause context by default. I do not think that's true at all. In fact, I would say that exceptions make it extremely easy to lose all context through the middle ground. Middle Earth is very difficult to get context from. Code that uses exceptions can run faster than code with inline errors. Yes, in stupid examples. I do agree. Dumb examples, you can definitely make it better. All right. Any serious application that require graceful handling would write their own allocators. Yes, I would assume that to be the case. Or they'd use something like Zig, in which requires allocators that handle those things already natively. Unless you are in charge of implementing a JIT or writing a compiler, but that's a one. Coming from a language like C++, which allows all sorts of things, I'm still a bit puzzled as to why newer languages like Rust or Go don't allow the use of exceptions. While you can definitely abuse exceptions, it kind of does. Go sort of does. Go has panic capturing, right? So you can actually recover from a panic. So in some sense, it has these fatal exception recoveries. But I've never tried to use one, so I've never been there. I don't know. While you can definitely abuse exceptions, functional style error values are not a one-size-fits-all solution. Whenever you're capturing context for an error message, you want exceptions. So we should be able to use them. Rust does as well. Okay, but idiomatic Go avoids panic. Yes, you avoid panic as much as you can. There's catch unwind. Okay. Oh, I just realized you need to know the function information in Dwarf to figure out what function is on the stack trace is the handler for that exception. So the missile knows where it is by knowing where it isn't. Nice. I was about to say that looks like a YAR one. Rust has also catch unwind. Tokyo explicitly does that when the worker thread panics. Okay. I was very excited about this article because I really wanted to hear some good reasons, and I really do like the one, which is more of a call out than anything else. That if you are doing potentially memory, if you're doing stuff, if you're working on a project that has capabilities, it might be good to think about level allocations. Zig obviously is a good choice. Rust, but having to do try new. But I really heard no great articles I heard no good argument for why exceptions are better than errors. Other than, I will say that coding as if you can just code happily with no error path coding considered does make it really easy to understand happy path coding. But I will say this, that 80% of coding feels like it's not handling happy path coding. It's actually thinking about and ensuring that things are really, really resilient. I find resilient code and error handling code to be significantly harder to write and harder to reason about, especially in a function that provides no path for handling that. So for me, writing that kind of stuff feels a lot better. And the exceptions are the 1 out of a million software considerations. They're not the consideration of your average person building a CLI tool, building a website, building any of these things. Your chance of getting an is exceptionally low unless, of course, you're using Slack, which somehow uses all the gigabytes. And the performance argument obviously makes no sense either. You're not throwing or handling errors. You're doing best case thing, right? Game physics engine is like the best example of this. Is more important in DBs, absolutely. But that's like a very obvious and distinct thing that you're doing here. But I would argue that there's better languages for databases. I think Zig is a superior language for a database. It's designed for that type of stuff. Now you can argue you could also do it in other languages. You're absolutely right. You're absolutely right. Absolutely right. Yeah. Yeah, I know, but I would argue this, it doesn't matter in the critical path, because in the critical path, if you have a critical path that needs optimized code, you will know you need optimized code in that path, and you will write code in which is optimized in that specific area. And when stack allocating errors as values becomes your most critical performance problem, then you can move on to that as a problem. But my guess is that is not your first, your second, or your third problem, and probably not even your fourth problem. It's just not even a problem likely for you. Death by 1,000 cuts. Typically I don't think of stack allocations as a death by 1,000 cuts. Usually there's a lot better reasons to get a death by 1,000 cuts that aren't going to be in that world. Usually it's you doing dumb things all over the place, just creating random allocations. Man, it feels like you're missing the point. What's the point, though? I'm trying to understand the point. Ghidra, tell me the point so I can understand it, because I am trying to understand it. I feel like the happy path one is extremely misleading, and I actually hate happy path only code. I feel that you have to have way more context, and that you end up hiding what the bad paths are, which makes it actually really hard to write good resilient code. Okay, so we're going to scratch that one. I feel like the out of memory one I said is a good one, because a lot of people don't even consider that one. But again, if you're writing out of memory applications, which is likely going to be databases, you're going to want, I don't even know other ones. I guess operating systems. What other applications are so memory intensive that makes sense? Catch all case is nice, even in the cases besides You can have all of this though. That's not a try catch. This is, my friend, this is not a try catch situation. Nothing about that is try-catch specific or errors as values. Neither side. So Ghidra, that argument is not a good one, because you can do that in either case. So we have to think of a different case. If you can give me a different case, I'm totally in. Something that makes sense, I'm totally in on buying that. How does a program run out of mana, though? Well, that's the secret of mana, but I'm going to hold on to. There you go. Oh, Ghidra, I would love another argument for whenever I see. So let me put it this way. When I see somebody who said, what if I want to search but not to blow up everything? Then you make errors. It's no different. If you want panics that crash the program, you write panics that crash the program. If you want errors, then you have to write it with errors. Now, I do agree. I think you're making a good point, which is you want to not have to color your function with error information. You just want something that handles the error. But I'm going to probably argue that generally is a pretty difficult situation. And typically global error handlers, are somewhere way far up the program to the point where, what do you do with this information? Now, what I assume you're trying to say is that this try-catch wraps a user request coming in, and that way you don't care how this thing breaks. Just somewhere down the line, it breaks and you return a 500. And you don't care what happens. You don't have a server that has state. You don't have to recover state at any point. I think they're referring to that as like the opposite of props drilling. Yes, it's the opposite of props drilling is what you're trying to say. I don't think anyone is arguing writing return-based errors is harder to write. It absolutely is. Absolutely. 100. Fully agree. But it isn't harder. It is harder. It is harder in the sense of writing it, meaning that every single function you have to consider all the errors at all points. That is fundamentally harder in short-term pain. But in long-term pain, I think it's significantly easier, because you must, at all points, consider errors at that point. Yeah, apologies. Yeah, okay, wait, yeah, sorry. I think I know what you're trying to say. I thought I understood until this thing, and then I think I misread it. But right, so more time consumer, easier to refactor though. It is easier to refactor by far. Let's just all agree that errors are a pain regardless of how they're handled, and that just something to and that is just something to accept. They will always have some overhead and will always be imperfect, but they are a necessary evil. It's just a difference of when they pay off. That's a fair way to put it. Errors will always be a part of all parts, right? Errors are everywhere. There is no escaping them. This is why I choose errors as values over exceptions. I want to know who errs, when they err, why they err. I want to be able to take that information and make decisions in my application at that point. For me, that's the best way to do it. Because sometimes I just want, on an error, to return false. Because this is just a filter function. I was unable to JSON decode it. I don't need anything like that. But this is an exceptionally easy oopsie daisy where you're not meaning to do a try catch here and you actually blow yourself up. Like you forget the try catch and you blow yourself up. It's very easy to forget some of these things. Whereas if you have errors as values, you cannot forget. It's inlined. It must be handled. It's right there in your face. You know at all points which functions do and don't error. That's why I like them. Anyways, all right. That was a wild one. I would have loved, by the way, Philip, I'm not trying to dunk on you. I'm sure you have good reasons for everything you're saying. And I bet you there's things that I don't consider because you do DB stuff. But I would have loved more examples for where it's actually easier and nicer. Because I'm not seeing anything easier and nicer. And you strawmanned errors as values by using C as an example with errno, which I kind of feel like is a little bit... Like, I know you probably have better examples, right? Anyways, hold on. I don't care. It's just semantics. I do care. Because I need to know if something fails. I do care. In some languages, errors are not reported. You don't know which function does or does not blow up. That's a real problem, okay? The name is the primogen. I'm all about non-hidden information. Explicit, best.